in this question, you have to compare the motion of the car X and car Y. As you see that we are given the velocity time graph of the both cars. So the car X is moving with a constant velocity according to this question. So if we draw this graph, let's redraw this graph. So this is a horizontal line that shows a graph, which means that if the graph of this car is the horizontal line, which means that the displacement time graph, dear students, displacement time graph must be uniformly increasing like this. And why is that? Because you know that the slope of the displacement time graph, position time graph, is the velocity. So velocity of x is v0 or v0, that is constant. So, and what about the car y? As we see that the car y velocity initially was 0 and both started from the same position. So in fact, this is our rectangular coordinate system. So let's assume this is x-axis, this is y, and this is z-axis. So both cars started from the origin. At the same time, this car x has already velocity v0, but the car y, its initial velocity was 0 meter per second. So in this question you have to find out that what car will be behind the other car. Okay, so we will make this solution interesting because I will show you different scenarios so you can relate with this question back. So the one is our displacement time graph, the one is this rectangular coordinate system, and the other one will be the equation, kinematic equation. So students, which car will be leading the other car? You can see in this graph I am clearly showing you that at the 20th second, which car has a more area, because this is an area that is representing the displacement or the distance covered by the car x. So we see that this area is more than which area. Okay, I'm coming to that point also. Look at this position time graph. This black line that you see is the for the car x. Why I'm saying, because we know that the car x is moving with a constant velocity, so that's why this must be the graph for the car x. What should be the graph of the car y? You can easily guess that its graph should be like this, or in fact like it was more steep. I should draw this kind of graph. So you can see that it is in the beginning it is not very steep, but as the time is going on it is becoming more and more steep. So what is the displacement at the 20th second for the car x, for the car y? So this is the car y and this is the car x. All right, so I have shown you the both things, the two methods. The one is the area under the velocity time graph, which we see is a clearly more for the car x. And if I draw the same graph for the car y, you see that its area is smaller than the area for the car x. So for more better understanding, I have clearly mentioned in this line. So this is a method one, and the second method I told you that you can see at exactly at the 20th second which has a more position. So of course the car x has covered more displacement from the origin. So the right answer for this question should be option A.